Okay, we have to start out by factorising this lovely quadratic here. As always with factorising, take care and use a grid or another method to check your factors really do multiply out to this. It's very slightly tricky because of the minus sign on the x squared term. Then on part B, this is effectively completing the square, except we're doing it backwards. We're given that the answer is this. So you can actually just multiply that out, again use a grid for squaring out the bracket, do it properly, and without cheating get to this answer. Why were we doing those things? Because they're setting us up for sketching this graph here. We've got a curve with the equation that we've been dealing with here and here, so we've already factorised it, put it in completed square form. And in 1 and 2, what we need for the line of symmetry and for the vertex is the completed square form, which is this one. But you may prefer to rewrite it with the squared bracket bit first. It will have a minus sign in front of it, but you don't much care about that, plus a number at the end. And the values of these two constants with one minor adjustment will give you the coordinates you need for the vertex. And once you know the vertex, the minimum point on one of those, or the maximum point of one of those, the line of symmetry depends on the coordinates of the vertex. Make sure you get it expressed correctly, starting with x equals y or y equals, as is appropriate for a vertical line. And the line of symmetry in the vertex should come easily from that. Then we've got to sketch it, so we've got to decide which of these cases we have got, looking at the x squared term. And we need to get the values of the intercept on the x-axis. That's true when y is 0. Here's y. When does that equal 0? Well, we've already factorised it, so we're well on the way to solving that. So 2x values where it'll equal 0 probably, and then the intercept on the y-axis is when x equals 0, and there's the equation. Put all that information on a graph, and you should cash in for marks, lovely marks.